So the Crystal Sync project has taken another turn to such an extent that it can't really be called a Crystal Sync project anymore. And this is because I'm no longer using a stepper motor, and that's because it wouldn't always start up reliably. It would seize while it was starting up, and the controllers just kept burning out. That's 2 controllers have burnt out now. So the only way to use a stepper motor with this would be to purchase a very expensive and large industrial controller. So I've decided to go for DC motor, just a normal brushed motor. This one is 24 volts, 4900 RPM. I will be running on 12 volts, and using PWM I will control the speed, and it will be much more reliable, and the camera can start up instantly. For the speed feedback, I'll simply be measuring the time between the shutter blades passing this sensor. So that will basically give me a time, and if it's shorter or longer than that, I can basically match it up with a time that I set for a specific frame rate, and that will give me a precision with an Arduino of about 7 frames per minute. So it would go out with sync maybe 7 frames every minute. If it's using an STM32 microcontroller, I can get the speed almost exact, but it's quite difficult to port the code over to those. So I might give it a try, but I'll just use the Arduino for now, and it should hopefully be fine. With this method, mounting the motor was actually easier. I just got a nice shaft adapter, 3.17 to 4mm. So basically I've just cut a slot in the end of that shaft adapter, just like what was on the stepper motor, but it's 4mm wide, and this cog on the camera in here has actually got just a little piece that sticks out into that, so it lines up perfectly. So it's going to be a better system with the DC motor. It will start up almost instantly, and it will be much more reliable. So what I'm trying to do now is just sort of balance the motor so it's running as smoothly as possible. I'm just trying to space it out, put spacers in just so it's sitting at exactly the right angle, because if it's at the wrong angle it has more resistance, because the shaft of the motor and the shaft of the camera are out of alignment. But I've got it pretty much right now, so I've just got to connect it up to a PWM controller. This will not be my final control method. I will be using the microcontroller to keep the RPM constant. So let's have a look. And that's about 25 frames per second right there. So it should be possible to control its speed reasonably well, but this is using a PWM controller which has a 555 timer inside it, so this is obviously going to be more accurate than Arduino. So as you can see, using this I could set the speed almost perfectly, but this isn't a good option, because if I put more load on it, so we'll get it to 25 again, so that's about 25, just about here. So if I was to put more load on this, what would probably happen is it just wouldn't stay constant, as you can see. So I need the Arduino to sort of keep track of that. So yeah, mechanically that's working really nicely. I'll just have to get the rest of the camera put back together. It's still in bits just now, and I'll be able to test all the mechanics and then get straight to work on building the new controller, which should be pretty simple. I think I've got it lying around somewhere, but basically where the stepper motor controller used to be, will just be quite simply a single MOSFET, and quite a heavy duty one at that.